Hey guys, welcome back. So I'm doing AMC 10A 2022, problem number 24. Now this problem is kind of crazy. Um, I worked on this one for a while. This might be the problem that I took the longest to work on because I was trying so hard to find a pattern or a formula or some way like to really get the grasp of this problem that doesn't involve like having to count situations and then subtract the ones that are double counted and then add back the ones that were triple counted. And I just hate that process of inclusion, exclusion. I get confused very easily. So another problem solving strategy that I remember learning in my graduate program is looking at a simpler case, looking at simpler cases and then seeing if you can find a pattern from the simpler cases. And luckily I was able to for this one, right? So I started by thinking, all right, well, let me read the problem. How many strings of length 5 formed by the digits 0, 1, 2, 3, 4 are there such that for each j belonging to 1, 2, 3, 4, at least j of the digits are less than j? For example, 0, 2, 2, 1, 4 satisfies this condition because it contains at least one digit less than 1, at least 2 digits less than 2, at least 3 digits less than 3, at least 4 digits less than 4. The string 2, 3, 4, 0, 4 does not satisfy this condition because it does not contain at least 2 digits less than 2. Right? So we need to form a 5-digit number out of 0, 1, 2, 3, 4, such that there's 1 digit less than 1, 2 digits less than 2, 3 digits less than 3, and 4 digits less than 4, right? So I started by thinking, well, what if there were only 2 digits? What if I could only pick from 0 and 1? I had to make a 2-digit number where there had to be at least 1 digit less than 1. I thought out, well, what are the cases? 0, 0, 0, 1, or 1, 0. So there's exactly 3 possibilities if you reduce it down to just 0 and 1. What if you have 0, 1, and 2? So I need 0 digits less than 0, 1 digit less than 1, and 2 digits less than 2. So I thought about, well, what are the possible digits that would meet this requirement? 0, 0, 0, obviously, 0, 0, 1, 0, 0, 2, 0, 1, 2, or 0, 1, 1, right? But remember, I can reorder these, right? There could be different orderings. So 0, 0, 0 only has one possible way. 0, 0, 1 has 3 possible ways because where do you place the 1? Same thing for 0, 0, 2. 0, 1, and 2, there's 6 because it's 3 times 2 times 1, right? And then 0, 1, 1, there's 3 because where do you place the 0? So adding those up, 1 plus 3 plus 3 plus 6 plus 3 is 16. So there's 16 possibilities when you reduce it down to 0, 1, and 2. Am I seeing a pattern yet? Not really. When I looked at 0, 1, 2, 3, that's when I noticed the pattern, right? So you'll see with this one, I listed out the possibilities. And again, this kind of a little tedious, but ultimately, in my opinion, not too bad, especially when you realize how many how many possibilities there are when you make it to 5. I think it's worth it to list these out. So what are your possibilities when you have 0, 1, 2, 3? Well, 0, 0, 0, 0, 0, 0, 0, 1, which there's 4 ways. 0, 0, 0, 2, there's 4 ways. 0, 0, 0, 3, there's 4 ways. 0, 0, 1, 1, there's 4 choose 2 places to place the 1s, which 4 choose 2 is 6. 0, 0, 1, 2, there's 4 places to place the 1 and 3 places to place the 2, and then the zeros will just be put wherever is left, so there's 12. Same thing for 0, 0, 1, 3. 0, 0, 2, 2 is the same thing as 0, 0, 1, 1. There's 4 choose 2 ways. 0, 0, 2, 3, 12, because again, 4 places for the 2, 3 places for the 3. 4 possibilities for 0, 1, 1, 1. 12 possibilities for 0, 1, 1, 2. 12 possibilities for 0, 1, 1, 3. 12 possibilities for 0, 1, 2, 2. And 24 possibilities, 4 times 3 times 2 times 1. Possibilities for 0, 1, 2, 3. Add those numbers up and you get 125. This is where I noticed the pattern, because I noticed that I knew 125 is 5 cubed, and I knew 16 is 4 squared, and 3 is 3 to the power 1. So you have 3 to the power 1, 4 to the power 2, 5 to the power 3, clearly a pattern. What would be the next in the pattern? 6 to the power 4, right? Is 6 to the power 4 is 1,000. It worked. Now, I will say I've watched videos of other people solving this problem, and there are some people who came up with very creative methods. There was one that I just seemed like way too much to follow. But there was one person who I watched who did it a very interesting way, which he actually used the method of complementary counting. So counting the number of strings of digits that would not meet these requirements. right? And it actually turns out that it's actually a pretty effective method. So, um, or knowing that the answer needs to be equal to 1 mod 5, because basically any possible string of digits you come up with, there's going to be some multiple of 5 in terms of its number of arrangements, because it's always going to be 5 factorial divided by something, right? Except for the case of 0, 0, 0, 0, 0. So it's always going to be a multiple of 5 plus 1. The only answer choice that's a multiple of 5 plus 1 is choice E. So I thought those were also very interesting ways to solve the problem. But I wanted to do it in a different way, not to steal somebody else's work. So that's the best way I can come up with. All right, I'll see you for maybe number 25. I'm debating whether or not I'm going to do it, but if I do, I will see you there. All right, bye.